everyone. Welcome to Radiant Math. Today, we're going to be talking about completing the square. This is a live tutorial, so if you're in the chat, maybe ask a question. If I'm explaining something that you wish I was explaining a little more thoroughly, feel free to leave a comment and let me know. I don't know that there's going to be many people here today, but I'm going to leave it up for future viewers. It'll just be up, so it's a live session now. It'll just be a regular session later. All right, let's get started. So, completing the square. A lot of times, completing the square seems like one of those topics that you're told to do, but you don't really ever fully understand it. So I'm going to go through a couple examples today, and hopefully in talking them through, it'll help. Okay, so let's take an example like this. Let's say you have an equation that looks like this. X squared plus 6x plus 3 equals 0. And you're told to solve for x. Well, of course, you can always use the quadratic formula, the quadratic equation, but completing the square is a technique that is useful when you can use it. So, and there's going to be times when completing the square is specific. So, you look at this and you say, okay, I don't really want to do the quadratic formula. Maybe we can factor this. And so you try to factor this and you go x plus something and then x plus something, right? But since this is 3, there's no factors of 3 that can multiply to 3 but then add to 6. So factoring isn't going to work. So what we do when we complete the square is we're trying to create something that looks like this. X plus something squared, right? If it was x plus 4 squared, it would look like x plus 4 times x plus 4, and we could FOIL that out and find it. But the way this equation, x squared plus 6x plus 3, the way it currently is, isn't useful for that. So here's what we're going to do. You're going to take this number here. We're going to take this and take 6 and divide it by 2 and square it. So 6 divided by 2, nope, that's not an equals. We're going to, 6 divided by 2 is 3. 3 squared is 9. So what we're going to do is we're going to take this back into our original equation and add 9 onto both sides. What we get when we do that is x squared plus 6x plus 9 plus 3 equals 0 plus 9. So on the right-hand side, it just equals 9. Okay. The reason that's useful is because this part here, this x squared plus 6x plus 9, now we can factor this as an x plus something that works out nicely. What are factors of 9? Well, there's 1 and 9, or 3 and 3. Let's try 3 and 3. If we were to square this out, you would get x squared plus 3x plus another 3x plus 9. And if you need help with that, if you need more clarification with why squaring this out gives you that original equation, drop a comment and I'll make a more extensive video on factoring and FOILing binomials. But for right now, we have x plus 3 squared. Well, that's great, but then we also have this 3, right? This is x squared. X plus 3 squared. We still have this plus 3 left over, which equals which still equals 9 because we had to add it to both sides. The reason we had to add this to both sides is because you can't just change one side of the equation without also changing the other side of the equation. Or in other words, if you only add plus 9 to one side, then you're changing the equality of the left-hand side and the right-hand side. We want the left-hand side and the right-hand side to still equal each other, so we have to add the same thing onto both sides. Okay, so back here we have x plus 3 squared plus 3 equals 9. Well, let's move that plus 3 onto the other side by subtracting it. And now we get x plus 3 squared equals 9 minus 3, which is 6. Cool. So what can we do from there? Well, from there, we can solve. Let's see. So from here, we say x plus 3 squared equals 6. Okay, well, what if we square root both sides? Now on the left-hand side, we're just left with the x plus 3 that was inside. And on the right-hand side, we get plus or minus square root of 6. Subtract a 3 off from both sides, and we're left with x equals negative 3 plus or minus square root of 6. Okay. So that is our first example of completing the square. And we're left with this answer here. So the key, what we're trying to do, is we're trying to take something that isn't a perfect squared binomial and turn it into a perfect squared binomial. And we do that by adding a specific amount to both sides. And that specific amount you get from taking b, dividing by 2, squaring it, and adding to both sides. Let's look at another example. Okay, what if we have something like this? 2x squared plus 16x plus 4 equals 0. Okay. Well, if we have 2x squared plus 16x plus 4 equals 0, it's going to work in a very similar way, except now the only difference is we have this 2 out in front. Well, what would we normally do with that? We'd notice there's a 2 there, a 16 there, a 4 there. They're all divisible by 2. So let's factor out that 2. And we'd have 2 parentheses x squared plus 8x plus 2 equals 0. Cool. Now we're going to go about this the same way. To complete the square, we're going to look at this middle term, 8. We're going to take that 8, divide it by 2, and square it. 8 divided by 2 is 4. 4 squared equals 16. So, based on the first example, we might think, okay, cool, we're going to add 16 to both sides. And it's very, very similar, but let's add it inside this parentheses first and see what that looks like. So, that's going to look like this. We're going to have a 2 parentheses, and now we have x squared plus 8x plus 16 plus 2 equals, so what do we need to add onto the right-hand side in order to maintain the left-hand side equal to the right-hand side? Notice if we're adding this 16, right, this 16 that we got from 8 divided by 2, which is 4, and then squaring it, we're adding that inside this parentheses, right, because we already factored out this 2. If you were to redistribute this parentheses, the 2 would have to go to each one of these things. And we'd have 2x squared plus 16x plus 32 plus 4 equals what? So when we added 16 inside this parentheses, really we added 32. So that's the only thing to make note of that's different when you're adding a number to complete the square when there's a number, when there's a coefficient out in front of your x squared term. So we're going to back this up. Now that we saw that, we're going to add 32 onto this side. Cool? Now, what we want is these terms by themselves. So in order to do that, we're going to get rid of this term. And by get rid of, I never mean just get rid of. We have to move it over to the other side or rearrange the equation somehow to isolate that term or to isolate the other terms. So just like how I said, if you were to multiply this out, this would have to go to each term. So 2x squared plus 16x plus 32 plus 4 equals this 32 on the right-hand side. So if we want to move this to the other side, we actually need to subtract 4. Oh, let's see. I'm writing in the blind spot. Let me leave that here. I'll just make myself a little smaller. Problem solved. So we need to add or subtract 4 from both sides in order to then wind up with 2x squared plus 16x plus 32 equals 32 minus 4 gives us 28. Okay, we're getting very close. Making this all a little bit smaller to write with. So I only redistributed this 2 here so that we could better see how to get rid of that 4. Now that we've gotten rid of that, let's put this back in parentheses. And we have a 2 parentheses x squared plus 8x plus 16 equals 28. Cool? So the key thing we did is that inside this now can be x times 4, or I'm sorry, x plus 4 times x plus 4. Right? Factors of 16, or 4 and 4, or 8 and 2, or 1 and 16, but 4 and 4 add to 8. So that's what we're going to choose. So this looks like 2 parentheses x plus 4 squared. This equals 28. So now we've completed the square. The last thing we have to do is actually solve this. I'm going to make this all smaller one more time, and we are going to solve this. So there's a 2 out in front of this. Let's go ahead and get rid of that by dividing everything by 2. That's going to give us x plus 4 squared equals 14. We have something squared on the left-hand side equals a number. We can solve that by square rooting both sides. And we're going to get what's inside the square root on the left-hand side, but without the squared. So x plus 4 squared, the square root of that, it's just x plus 4. And this is going to equal plus or minus 14. Plus or minus square root of 14. I'm going to subtract 4 from both sides. And we're going to get x equals minus 4 plus or minus square root of 14. Awesome. So those are 2 examples of how to complete the square. One with a coefficient in front of your leading x squared term. The other with just the x squared term. If you need more examples, if you want further explanation on any steps that I did, leave a comment and I'll make a video about it. This is just my first live streaming of a tutorial, so feel free to let me know other topics that you'd like me to cover, and stay tuned for next time. Like and subscribe, and hopefully I'll cover what